gallon to milliliter part first. It's still going to be a line of conversions here, where we set things up in order to cancel out. For no particular reason, I'm going to do the gallon part first. But gallons is a denominator unit, that's why it's written down there. Which means when I go to use this relationship, gallon is going to have to be a numerator unit. And gallons is going to convert to liters. So that's gallons on top, liters on bottom. One goes with gallons, 3.785 goes with liters. Now that's not quite where we want to be because we need to be in milliliters, not liters, correct? So still on the volume part, we need to convert from liters to milliliters. And you do need to have memorized that that milli prefix is 10 to the negative 3. One times 10 to the negative 3 liters is 1 milliliter. Now this is a very common place where people make a mistake, so I'm going to color code this. Do whatever you need to do to make this distinction in your notes. That milli means 10 to the minus 3, correct? Literally, that's what it means. And so I'll plug this in to where I keep the number 10 to the negative 3 and the symbol for 10 to the negative 3 away from each other. If you do that, then you're not going to make mistakes. Because what people tend to do, I've seen this lots of times, they'll know what milli means, but they'll write it like this. You've already got 10 to the negative 3 in the denominator, correct? You're not going to put it in again. What you need to get in the habit of doing is keeping the value and the symbol away from each other. And that way it will take care of itself. This is 1 times 10 to the negative 3 liters. This is also 1 times 10 to the negative 3 liters. It reads the same in both. It is the same in both. Question with that one term and what I've highlighted there. That is an extremely common mistake. All right.
I have a question. What are some good ways that I can know that, make sure that I know that?
First of all, you've got to memorize what those prefixes are. That milli is 10 to the minus 3 and it's a lowercase m. Kilo is 10 to the positive 3 and it's a lowercase k, and so forth. If you memorize what each one means, and then you memorize to always keep them separate, then that should take care of it. Now at this point, gallons will cancel and liters will cancel, and my denominator unit is milliliters, exactly like I want it to be, correct? So denominator-wise, I'm done. I need to go back and work on the numerator. I need to get pounds to grams. Pounds is a numerator unit, which requires me to make pounds a denominator unit. And I don't have a relationship that will get me to grams, but this will get me to kilograms. So I can set this up and go from pounds to kilograms, and then separately kilograms to grams. This part here is the volume part of the conversion. This part here is the mass part of the conversion. But ultimately, the key to the whole thing is cancellation. Pounds, this is 1 goes with pounds. 0.4536 goes with kilograms. And what does kilo mean numerically?
10 to the third.
10 to the third. So 1 kilogram is 1 times 10 to the third grams. Again, just like in this other step, keeping the symbol 10 to the third and the number 10 to the third deliberately away from each other. Now that works out the units because this is pounds on top, cancels with pounds on bottom, kilograms on top, cancels kilograms on bottom. The only unit left on top is grams. The only unit left on bottom is milliliters. That's where we want to go. And then you do the numbers. But if you set something up like that and you go back and inspect your units and your units don't work out the way they're supposed to, then don't even bother reaching for your calculator. Because if the units ain't right, the numbers ain't going to be right. Take the time and make sure the units work out. Everything on top is going to be multiplication. Everything on bottom is division. So typing it in the calculator, it would be this divided by this times this times this times this. Top means multiply, bottom means divide. You get your answer, and when you get that answer, you're going to cut it off to 3 significant figures. Because if you remember back to when we did that multiplication division rule, you were limited by the data point with least significant figures, correct? Nothing over in here is data. Those are conversion factors that are given to you. The only experimental number you've got is this. That 8.34 is your only data point. And therefore, 3 significant figures on it is going to carry through just 3 significant figures in your answer.
Also, wouldn't there be a 1 next to gallon? Oh, it'll be a 1?
Yes. Mm-hmm.
So would that cut down the gallon, the significant numbers?
No, because it's defined that way. It's kind of like miles per hour. It's assumed to be exactly 1 hour. This would be exactly 1 gallon.
Yeah.
So no, that's not going to limit you. In general, conversion factors never limit you. It's experimental numbers that limit you. Question here on number 5. Do you see how these units are canceling? It's all in the alignment of it. If not, please ask.
When I do mine, I do 1,000 milliliters in 1 liter instead of, do you care if we do it that way?
You can do it however you want, as long as you show your work. Okay, but I'm not going to do that on the board. At least, I mean, I have it. Sometimes I do,
Okay.
but I try to avoid that just because that is a little bit more mistake-prone than this. And so, what I'm trying to do on the board is what seems to me to be the safest route. Other question? All right. Section on density. The other day when we first started talking about matter and energy and definitions for those, the definition for matter came out as anything that has mass and occupies space. Density is just the ratio of how much mass is crammed into how much space. Density is equal to mass over volume. How much material there is per volume. Next week in lab, the experiment that you do is going to involve density. If you've had lab this week, you've got a little practice exercise with it, but Next week's lab will give you even more with density. And that's because density, for liquids at least, is an identifying characteristic of the material. No two substances have exactly the same structure, and therefore no two substances are going to have exactly the same density. And so if you can find differences in density, that goes a long way toward helping you identify exactly what that material is. And you do that by taking a certain volume of it, that means you know the volume, and you go weigh it. That way you measure the mass. The ratio of mass to volume gives you density. Now, typical units, if you're measuring a solid, now this is typical, not always, but generally it's going to be grams per centimeter cubed. It won't always be that, but it's usually that. If you're working with a liquid, it's typically grams per milliliter. And if you're working in gas phase, it's generally grams per liter. And as a side note, look at these two definitions and where they differ in the denominator. They don't really differ in the denominator. Because 1 centimeter cubed is the same thing as a milliliter. Or if you're used to medical stuff, 1 cc, 1 cubic centimeter. That's all the same. 1 cc is exactly 1 milliliter. Emphasis on exactly, meaning that's not going to affect significant figures in any way. So that means these two really are the same thing, aren't they? All right. Question number 6. We've got this object, it's a piece of metal. We know its length, width, and thickness. Seven inches, 5.10 inches, 0.25 inches. That's the dimensions of it. And it weighs 920 grams. This is our experimental data. We want to calculate density, specifically when we want that in grams per centimeter cubed units. Let's do the easy part first. What's the gram part going to be? 920. Now the volume part is going to be considerably more work, because what we need to do is convert each one of these distances out of inches and into centimeters. And I'll give you the relationship for that in just a second. I'm going to write this over here so it's a little bit larger. Before we even think about numbers, where is inches units going to go?
Bottom.
Got to go on the bottom. No option, right? Absolutely no option. So then if you're given the relationship that 1 inch is 2.54 centimeters, then you know what to do with that. Because inches has to be on the bottom, so centimeters has to be on top. Numerically, 1 goes with inches, and 2.54 goes with centimeters. Emphasis on no option. It's got to be that way. And that'll give us a conversion into centimeter units as opposed to inch units. And I'm not gonna, since we're kind of in the middle of the calculation, I'm not gonna worry about significant figures just yet. Once we have our final number for density, then we'll go back and talk about significant figures. But right now, the calculator says 17.78, so I'm just gonna go with that. So what I've got at this point is length, width, and thickness in centimeter units rather than the given inch units. Question about anything there? Purposely not worrying about significant figures yet. We'll do that at the very, very, very end. But we're now in the middle of the problem. That's what we've got. Now for something that's rather, I guess, rectangularly shaped, length times width times height or thickness, that's a volume. So what we need to do for that rectangular type object is multiply length times width times thickness. That's going to give us a value that we can use for volume. Unit-wise, centimeters times centimeters times centimeters is how you get centimeters cubed. The unit thing still follows. So 17.78 times 12.954 times 0.635 is 146.2545462 cubic centimeters. Length times width times height. That's where this volume is coming from. So we got our mass, we got our volume, we plug those both into the definition of density, we divide through to get the answer. And the calculator says 6.290402753 units would be grams per cubic centimeter. Is everybody getting that? Because that's almost right. In order to be right, we've got to cut it off to the right significant figures, correct? Look back on the right-hand board, the four numbers that you were given as data. How many significant figures in 7.00? 3. 5.10. 0.25. And 920. Good. So how many are we going to be limited to in the answer? 2. Which makes your final answer what? This keeps, everything else rounds, that rounds up, so 6.3 grams per cubic centimeter. 6.3 would be the properly phrased answer. question with that? Comfortable with it? All right, look at problem number 8. Now, what we just did with problem number 6 was take experimental data, mass and volume, and calculate density. And sometimes you do that, but most of the time when you're doing a density calculation, you're not calculating density. You're using density to calculate something else. And that's what you've got on problem 8. We have 50 milliliters of ethanol. We're told that ethanol has a density of 0.789 grams per milliliter. And we want to know how much that 50 milliliters is going to weigh. The density tells you that 1 milliliter weighs 0.789 grams. That's your conversion factor. Now you can set this up in a couple different ways, but the safest way to do it is when you can start off your calculation with something that just has a single unit. You've got 2 numbers that are given in that problem, correct? But you're given 3 units in that problem. Correct? Things that have top and bottom units make very good conversion factors, but they're very risky starting points. If you take something like this as your starting point, then everything else will have to align with it. But sometimes, with these conversion factors, maybe it's supposed to be grams over milliliters, but in other times it may be milliliters over grams. You use it, however, it's going to cancel the units. So it's a little bit risky starting with something that has top and bottom units. It's always safer to start with a single unit if you can. In this case, we can, because we have that. 50 milliliters treated as numerator. Which means when we set this up, milliliters is on top, we're obligated to milliliters on bottom, which puts grams on top. That's 1 milliliter, 0.789 grams, correct? Question on number 8 here. How many significant figures in your answer? 2. Because of the 50. Conversion factors don't limit you, but experimental numbers do. So it's going to be 2 because of that 50. 50 with a decimal is what makes it 2. Do number 9 on your own, given this relationship. purposely not putting numbers in yet because numbers are a side issue. The main thing is the units. Do you see why the units have to be aligned this way?
Cancel.
Cancel. We're going from pounds to grams and then grams to cubic centimeters. You're not given a conversion that will take you directly from pounds to cubic centimeters, so we kind of have to stack them there. So we're going indirectly from pounds to grams and then grams to cubic centimeters. And once we know for absolute certain that the units work out the way we want them, then we can go back and start thinking about numbers. 1 pound, 453.6 grams, 2.70 grams, 1 cubic centimeter. And then you do the numbers, and then you round it off to 3 significant figures, and then you're done. Question? Are you getting what you should? Yes? All right. If there's any question, please ask. Next section on specific gravity. Now, specific gravity is one of these things where defining it makes it look more complicated than it really is. Specific gravity basically is a relative density. By formula, official type formula, specific gravity is equal to the density of whatever material you're talking about here. I'm just going to call it X. Density of material X divided by the density of water. Now, just preliminary here. If the density of water is measured in grams per milliliter, and this other thing you're measuring, for consistency's sake, you need to also measure it in the same units. If this is a ratio of grams per milliliter over grams per milliliter, then what's the units going to be at the end?
Grams squared per milliliters.
That would be multiplying. What's grams divided by grams?
1.
What's milliliters divided by milliliters?
1.
There are no units. This is simply a ratio. Specific gravity is just a ratio. It has no units to it. It's just a multiplier that tells you how many times denser something is compared to water. If you look at the little chart here, you've got 3 columns. The first column tells you the density of water. If you're measuring the density of water in units of grams per milliliter, then the value is 1.00. But if instead you're measuring it in water in pounds per gallon, then the number is 8.34, and so forth, 62.4 pounds per cubic foot. The difference in number comes from whether you're measuring 1 milliliter, a whole gallon, or a whole cubic foot. All 3 of those are just plain pure water. Are we okay with that? It's 3 different ways of expressing the density depending upon the units you're dealing with. Now look at the next column over. If you've got a material that has a specific gravity of 2, then that means it's twice as dense as water, correct? All this is a unitless multiplier that tells you that this particular substance is twice as dense as water. Whatever units you're talking about, it's twice as dense as water. So if water has a density of 1 gram per milliliter, then what's this other material's density? 2 grams per milliliter. If water has a density of 8.34 pounds per gallon, then what's this other thing's density? 16 point something, right? Whatever twice 8.34 is, right? And if water's density is 62.4 pounds per cubic foot, then you double that, and that's the other guy's density in pounds per cubic foot. Regardless of units, this other material is twice as dense as water, period. Specific gravity is nothing but a multiplier that helps you make ratios. Hopefully you're writing numbers in that column. 2.00 grams per milliliter, whatever double 8.34 is, whatever double 62.4 is. Now the last column is somebody that is less dense than water. 0.75 is less than 1, correct? That means it has a lower density than water. But still, that 0.75 is a multiplier. If you take that 0.75 and multiply it by water's density, you'll get this material's density. Go ahead and fill out that column.